Good afternoon. My name is Tanmay Kayande, and for the last decade, I've been the trusted advisor for executives from startups to SMBs to enterprise-scale organizations. I've found patterns in the architecture of those that lead their field. I know because I've designed and developed their systems and processes using AI, platforms, models, and frameworks to positively affect billions of users, and now bring my insights to you. Welcome to session 10. For the past 9 sessions, we focused on many techniques that we as humans can use to manually craft better prompts. But what if we could use AI to do some of that hard work for us? Today, we're going to discuss how to automate the process of creating and refining prompts. By the end of this session, you'll be able to define automatic prompt engineering, or APE. Second, outline the process of using an LLM to generate and evaluate new prompts. To get there, we'll cover 2 key concepts: what automatic prompt engineering is, the 3-step process for using one LLM to generate and help you evaluate prompts for another. All the details for the APE method, if you're following along on the white paper, can be found between pages 40 and 41. So what is automatic prompt engineering? APE is a method of using large language models to automate the creation of prompts. This technique can alleviate the need for extensive human input and can even enhance the model's performance on various tasks. The core idea is to have a prompt that writes more prompts. This works by following a clear 3-step process. Generate. First, you write the prompt that instructs the LLM to generate many different instruction variants or candidates for a specific task. For example, you could ask it to create 20 different ways to start a conversation at a networking event. Next, evaluate. You're going to take all of the generated prompt candidates and you score them. You can create your own way to score, use it for professional use, or go by intuition for personal use. For technical people, the NLP evaluation metrics recommended are in the description, and you can use those to objectively measure which prompt produces the most accurate and desirable output. The third step, finally, you select the instruction candidate that received the highest evaluation score, and this becomes your new optimized prompt to use in your application. The white paper also notes that this is an iterative process where you might tweak the best performing prompt and evaluate it again. I'll deviate again from the white paper with an example from a sales side of, let's say, a business analyst perspective. Imagine there's a business analyst that works with your sales team and they need to analyze sales data to find insights. The manual approach might be to prompt analyze the sales data and find insights. The APE approach would first say to the LLM, create multiple analyses framework, test each on sample data, then use the best method. With APE, the following prompt is written. So generate 5 different analysis methods, test each method on sample data, select best performing approach, and apply optimized method to real data. Rather than hoping the one method the analyst knows is effective and sufficient, they use APE to get AI to find what works best. You regularly use an LLM for the same type of task, like writing product descriptions, but you're not sure if your current prompt is optimal. Instead of tweaking it, what technique could automatically find a better prompt? I'll give you a couple seconds. Use APE by asking the LLM to generate 5 different prompt templates for product descriptions, test each one on sample products, and then select the template that produces the most compelling descriptions. The main thing to remember is that automatic prompt engineering is a process of using AI to write and test prompts for you. The core loop to remember is generate, evaluate, and select. APE is a fantastic way to optimize prompts for a wide variety of tasks. One very common and important task is getting the LLM to output perfectly structured data like JSON or even computer code. In our next session, we'll focus specifically on prompting for structured tasks. Thank you. I'll see you there.